In this video, I'll be taking you through characterization of zinc oxide nanoparticles using 4 techniques: UVVs, PL, Raman spectroscopies, and XRDs. And these techniques are employed to confirm the identity of the previously prepared zinc oxide nanoparticles and to determine some of its properties. UVVs and PL use electromagnetic waves that interact with the sample and hence give information about the optical properties of the sample, such as the band gap and the emission properties. In XRD, the sample is bombarded with X-rays, and the scattering angle as well as the intensity of the ejected X-rays measured, and then the pattern, the XRD pattern of the zinc oxide nanoparticles compared to the reference zinc oxide XRD pattern. The crystallite size will then be estimated using the Schwerer equation from the first 3 peaks of the XRD pattern. Raman spectroscopy, on the other hand, gives information about the type of bonding that is present in the sample, the type of environment the sample is in, as well as the type of stress that the material experiences. In this part of the experiment, the absorption peak of the zinc oxide nanoparticles in ethanol will be determined using UVV spectrometer. For our sample preparation, we are going to need a sonicator, absolute ethanol, a cuvette, a vial, a spatula, our zinc oxide, as well as a beaker. We'll then take our vial and we'll take a spatula tip of our zinc oxide and then place it in the vial. And then we'll pour absolute ethanol on our sample. We'll then close our vial and put it in a beaker with some water, and then put it in the sonicator and sonicate for around 10 minutes. We'll then switch on our spectrometer and our computer. And while that is heating up, we'll then put some ethanol in the cuvette. And then we'll open the Aspect UV program. And then we'll go to Method Setup. We'll then put our cuvette in the sample compartment. And then we'll change our nanometer range, our scale, from 400 to 800 nanometers. And then we'll click OK. And then we'll click on reference, since we are measuring the absorption of our reference first. And then we'll click yes. And then we'll close that. We'll then take our cuvette out, take out the ethanol, and then we'll take our sonicated sample and then put it in the cuvette. We'll put the cuvette in the sample slot and then click on measure. And then we'll save our spectra by going to File and then Export Measure Values, Save in Data. And then you can open your file name. And then you can name your sample. Zinc oxide. And then click on Save, and then we'll go to File again, and then Save, and then go to Data. And then Save. In this part of the experiment, the PL spectrum of our zinc oxide nanoparticles in ethanol will be determined using a PL spectrophotometer. For our sample preparation, we are going to need a sonicator, absolute ethanol, a cuvette, a vial, a spatula, our zinc oxide, as well as a beaker. To prepare our sample for PL analysis, we'll then take a spatula chip of our zinc oxide, place it in the vial, and then add some absolute ethanol. And then place our vial in a beaker with some water. Place it in the sonicator and sonicate for 10 minutes. We'll then switch on our PL spectrophotometer, and then we'll place some ethanol in the cuvette. And then we'll place the cuvette in the sample compartment. And then we'll wait for a few minutes for that to heat up. We'll then open the scan program on the computer. And then we'll go to Setup. We'll go to Setup, and then we'll change our excitation wavelength to 300 nanometers, and we'll scan from 400 to 800 nanometers, and then we'll click OK, and then start. So that is our reference sample, and then we'll click OK. When that is done, we'll take out our cuvette, and then we'll place our sonicated sample in the cuvette. We'll then place the cuvette in the slot and then click on Start Again. So that is our zinc oxide sample. So if our sample goes to, the intensity goes to above 1000, it means our sample is concentrated. So we'll take out our cuvette and dilute our sample with some ethanol and then rerun the sample. We'll then put in our slightly diluted sample back into the slot and then start again. So now that is done, we'll then save our spectra by going to File, Save As, and then save our spectra as spreadsheet ASCII and choose a file. Or we can open a new file. And then we can save it as zinc oxide. Save. And then to terminate our analysis, we'll then switch off, close the program, and then switch off the spectrophotometer. And take out our cuvette from the sample compartment and close it. In this part of the experiment, the XRD pattern of the prepared zinc oxide nanoparticles will be determined using a D2 phaser diffractometer. It is important to know that different diffractometers can use different X-ray sources. And for this particular diffractometer, cobalt will be used as the X-ray source, whereas the diffractometer at MMU uses copper as the X-ray source. As such, the spectra can show a shift in the peak position. For our sample preparation, we're going to need a zero background holder, a spatula, our zinc oxide, glass, and any alcohol, and in this case, we're going to use isopropanol. So firstly, we're going to clean our holder with the alcohol and some paper towel. And we'll clean the glass as well. And then we'll take our zinc oxide, put it in the middle of our holder. And then we'll use the class to pack it down. And then we'll analyze this. We'll then open our diffractometer. And then we'll put our background holder on the stand. And then we'll close. And then we'll put in our sample ID as zinc oxide. And then we'll select an experiment. So we'll scan from 5 to 90 in 12 minutes. Open that. And then we'll save that as 0228. And then we'll click on Start Jobs to start our analysis, which we'll see on this graph. So once we have acquired our spectrum, various programs can then be used to process the data, such as to remove the background noise or to then match our spectrum to the reference zinc oxide XRD. We'll then take out our sample. And then close the diffractometer. In this part of the experiment, the Raman spectrum of zinc oxide nanoparticles will be acquired using a 785 nanometer laser. So for our sample preparation, we're going to need some ethanol, our zinc oxide, a spatula, sample container for the Raman spectrometer, and some paper towel. So we'll start first by cleaning our sample holder with some ethanol. And then we'll pack our zinc oxide in the sample holder. Oops. And then we'll remove any excess zinc oxide. And then we'll place our holder on the stand at an angle. And then we'll switch on our spectrometer. And turn on the laser. We'll then open our Lab Spec 6 program. And wait for the detector to be green. So we'll then press on play button to display our real-time display screen. And then what we can then do is to change our retention time and the laser power in order to improve our spectrum while it's on live acquisition. So we can change the real-time retention time to maybe 20 and see if our spectrum improves. Or we can change the laser power. Maybe we can change it down to 2. So you keep playing with the retention time and the laser power until you are satisfied with how your spectrum looks. So we can then, if we are satisfied with our retention time, we can then put that time into the acquisition time as 30, leave our laser power to 2, and name our sample zinc oxide, and then we'll click on stop to stop the real-time acquisition, and then we'll press on start to then acquire our spectrum. So now that we have our spectrum, we need to save it on the save data icon, and then we go to data and then open a new file, zinc oxide now, and then we'll save our spectra as text and then click save, and then that is done. So to close down our program, our analysis will then close the program and then switch the laser off and then switch off the spectrometer, and then take out our sample. And then clean our sample holder with some ethanol. And this concludes the video on characterization of zinc oxide nanoparticles using UVVs, PL, Raman spectroscopy, as well as XRD.